What is the perimeter of this shape that was created with algebra tiles? The perimeter is the length around the outside of this shape, and most of these pieces are fairly easy to calculate their lengths. So as I go around, if I start at this corner and I go to this spot, I just traveled a length of x. So from here to here is x units long. And then as I walk along this next piece, this would also be x units long. And I get that because I know these are squares, and the area of each of these squares is x squared. So that means the dimensions of it has to be x. So these are all x by x. As I move along, because this has an area of x, and I already know that this has to be x long, that makes these have to be 1. So these are it's a unit dimension there. So I've got 2 x's so far, plus a 1, plus a 1. This is 1 long. This is 1. This is a unit. This is 1. Now, this dimension right here is one of the special pieces, right? It's where there's some overlap between two pieces, and figuring it out it's not that difficult, but it's definitely not 1. So how long is that little piece that I've marked in red? Well, I know that this entire length that I'll mark in green is x units long, and I can see from that I'm subtracting a 1 and another 1. So this piece down here that's marked in red has to be an x minus the 2 1s that I've marked in green, right? So this piece is x minus 2 long. And I'm just going to leave that there as something we're going to have to include in our answer, but that's one of 2 special pieces. Now as I move around the rest of this, this is 1 unit, 1 unit, this is x units, and then I have a 1 and a 1. So I'm at this point right now. And here's another one of these special pieces. It's from here to here. It's not x units long, and it's not 1 unit long, right? How long is that piece? Well, again, the thinking's the same, right? This dimension is x, and this dimension from here to here is 1. That means that this little dimension here, right, has to be the full length, the x, and then it has to be 1 less than that. So this is x minus 1. So that was the second kind of special dimension that's on this perimeter. If I fill in the rest of them, this is a 1, a 1, a 1. This is 1 unit, 1 unit. And finally I end with an x right there. So I'm going to save these, but I'm going to count up everything else. So if I count up the x's that I see on the perimeter so far, I guess I'll highlight these in red or yellow. So there's 1, 2, 3, and 4. So far, I know that my area has 4 x's. And then I'm going to go along and highlight in green all the units. So I've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, and 15. So I can see that in addition to the 4 x's that I have to add 15 to my perimeter. And the other thing that I need to include are these 2 special pieces. So to this I'm going to add an x minus 2, and I'm also going to add an x minus 1. So as I look at this, I can see that I have some like terms, right? So for example, 4x and this x can all be combined to give me 6 x's. So I'll just go ahead and rewrite that. That's not 4, or not 5, but 6 x's. And then you can see I also have this 15 minus 2 minus 1. So this is 15 minus 3, or plus 12. So the perimeter all the way around is 6 times x plus 12. And the tricky part is those parts where some of the tiles overlap, and you have to calculate what the special parts are. So 6 times x plus 12 is the perimeter.